Hey, good morning or afternoon, whenever you're watching this. We're talking about Calc 3 series. We're doing question 89 out of the topic. This one is asking us to maybe think about some other strategies that you can do with the notation from sums. In this case, we're going to change the index from n equals 1 to, well, let's just make the bottom part of the summation is the issue. Let's make that equal k. N plus 1,000 equals k, and we'll call that a k value. So if n equals 1, then we're going to make k equal 1001 because you're starting at 1 and you're bumping it forward. You know what? Both of these actually have the same result. That's why we're allowed to do this. We're saying that even though the series is defined along this pattern, we're just shifting the pattern further to one side. And in that shifting process, we're allowing us to look a little further up the line. And then the sum of 1 over k, that actually equals infinity. If you add up ever smaller amounts, you can still always add a little bit more. And so even if you have to go out in innumerably far distance out there, you are making this sequence converge to infinity. There may be more formal definitions for why it converges. We certainly will try to talk about them as the course moves forward. Here's another one. Let's use that same idea with this one, the same idea as the previous problem, to try to define what k value we should be using and how we can get equivalent summations, but what needs to change. And really, it's all about the fact that if k is some relationship of n, and we're starting with n equals 1, then k is n plus 1. And once again, we get another series, and that series is divergent. The summation of 1 over etc. is going to continue to add up. We want to take a look at this 1 over n idea as elements of a sequence, 1 over n, 1/2, 1, 1/2, 1/3, 1/4, 1/5, 1/6, etc. Those elements of the sequence are graphed out there. It doesn't matter if we are shifting right or left, technically left if we do n plus 2. So all of the elements of the sequence are the same, they're just shifted over to the side. Now, however side that is, they're still the same sequence. They still eventually get infinitely close to, well, the same answer. Question 89 says the summation is n equals 1 to infinity of 10 to the power of 1 minus n. Well, we can do some tricks here. We can break apart, and again, the video kind of gets choppy here, so I'm sorry, just do our best to stay with it. But we can break apart using exponent properties, some things that we can do. We can break apart the n minus 1, the 1 minus n, which means 10 times 10 to the power of negative n. That 10 is a constant in the beginning. It gets to be factored out. And then we're looking at how this sequence relates to the sequence of 2 to the power of negative n. Certainly it converges by something called the squeeze theorem or sandwich theorem. We'll talk about it. Thanks for watching this video. Have a good day.